Hello students, welcome back. Now let's go to section 3, standard normal probability distribution. We went through a normal random variable, and the normal random variable had this kind of feature. No, where is it? Yes, this kind of feature. Unimodal, symmetric, mean, median, mode, they're all the same at mu, the mean. And let's consider a special case where the mean is 0 and the standard deviation is 1. We have this kind of picture. In this case, people already did a lot of computation and created something called the standard normal table. And here's the instruction for using standard normal table, but it's going to be very difficult to understand what the heck that instruction is all about without an actual example. So instead, let's go to an actual problem, an example problem down here, and then let's discuss how to use the standard normal table from, well, these 3 computation problems. Alright, ready? Okay, here we go. Find out the probability that z is less than negative 1.64, where z is the standard normal random variable. Okay, in this case, in any normal case, as a matter of fact, the most important thing is to draw a picture. So how do you start? Well, let's go to a drawing mode. Alright, and then let's draw a picture. First, an outline of normal picture. It doesn't have to be really that pretty. And then centered at 0 because this is standard normal. And now, where is negative 1.64? Is it to the left or to the right? This says negative 1.64, so it's to the left. Does it make sense? Finally, do I shade left or right? Z is less than negative 1.64, and in mathematics, less is to the left. So shading is to the left. So we are looking for the area of this shaded region. And please keep this picture. As a matter of fact, get a piece of paper and draw it by yourself. You see? Moving your brain and eyes, okay, that's good, but it's not as good as moving your hand as well. That really, really helps. And practice drawing a picture. Because the picture will be the necessary component of the justification of my exam problem. I will explicitly write a sentence like, justify your answer with graphical justification, or something like that. Not just algebraically, but graphically, both graphically and algebraically. And then my grading scale is like this. For a normal problem, for any usual problem is 10 points in exam, and 4 points for the picture, and 4 points for the algebraic derivation, and 2 points for the answer. If you just write the answer, 2 points, and you earned it just 2 out of 10. If you do all those algebraic justification perfectly, then you're going to get 6 out of 10. If something is wrong, then 5 out of 10, or maybe less. Now, if you draw the picture, and then you screw up somewhere, then even with wrong answer, you can get 7 out of 10, 8 out of 10, or 9 out of 10. So what do you think you should do? You should really, really, really draw the picture. Not just that, drawing a picture will actually help you think and help you get the right answer. So, draw a picture. That's really important. I mean, I could have just clicked this open and show you the computer-generated picture, but I took time drawing this using my mouse and this drawing mode. There's a reason for that. I wanted to force you to do the same. Okay, that's the picture, and then prepare it in your paper somewhere, because in order to proceed further, I have to get out of this drawing mode, and I'm going to lose this picture. Okay, let's get out of this drawing mode. And here's a picture, a little bit better picture because this is computer generated. And we have the shading. And now let's work on the normal table. And this table is provided. And in Canvas, it is posted. And this is the normal table, the first page and the second page. Let's go back to first page. We have this picture, left-hand side shading, and z-value is all negative. Now let's go to the second page, left-hand side shading again, and z-value is all positive. So that's what we are going to be working on. It's a bit annoying, so let's move it as much as possible. Now we wanted negative 1.64, right? So let's go look for negative 1.64. Z-value is here in the first column, and it gives you up to first decimal digit, negative 1.6. Where is it? Right here. So negative 1.6 here, and then 404 is over there. I scrolled a bit too much up, but in drawing mode, it's a bit difficult to change. Sorry about that. And then the probability value, the left-hand side shading is 0.0505. It's in 1.6 row here, and it's in 04 column. So we have 0.0505. That's the answer. All right, that's the answer. Let's get out of this drawing mode. And let's come back to the notebook. 0.0505 is what I found out from the normal table. But here in Mathematicas computation, we have more decimal digits. It has up to, let's see, first one is 0, so we have 6 effective decimal digits. That's Mathematicas default. So this one is a little bit more accurate, but if you use normal table, you're going to get up to 4 decimal digit. 0.0505, that's the answer. Remember, everything here, all these numbers here in the normal table, they're all about left-hand side shading. And that's why we have this picture here. Okay, now let's go to the next problem. The probability that z is greater than or equal to 0.62. Oh, by the way, whether we have strictly less than or equal to, that makes no difference because we are dealing with the normal random variable, a continuous random variable. So the concentration, the contribution of just single number, that's 0. So whether we have strict inequality or semi-inequality, it makes no difference. Now, greater than or equal to 0 or strictly greater than 0 makes no difference. But less than versus greater, that makes difference, you see. In mathematics, less is to the left. More is to the right. So this one is going to be right-hand side shading. Does it make sense? Let's go to the drawing mode. For problem B, you're going to get this kind of picture. Here's the outline. And then centered at 0 because this is standard normal. And then 0.62 is positive, so it should be on the right-hand side. Now, shading is for greater than 0.62, so it should be shading to the right, not to the left. Make sense? So this is important, and keep this picture. Oh, by the way, 0.62. Okay, 0.62 is there. Keep this picture. I'll have to get out of this drawing mode, so I'm going to lose this picture soon. So draw a similar picture in a piece of paper and keep it. All right. Now, let's go to, I'll have to open up that normal table, so I'll have to get out of this drawing mode. So I'm going to lose this picture. Okay, where's my normal table? Here we go. And Okay, here's a table, and 0.62, that's positive, so we have to go to the second page. And 0.62, yeah, it's right here. 0.6 and 2, so okay, z value is 0.6 and O2 is the second decimal digit. So the probability we are looking for is 0.7324. And record this in a piece of paper too, because when I get out of this drawing mode, I'm going to lose this highlighting too. 0.7324. Is that the answer? Compare that with your picture. Is that the answer? 0.7324. 0.7324. Well, 0.7324, but that's the left-hand side shading. What we wanted there was actually the right-hand side shading. You see? This is not what we want. This is what we want. We draw this picture, right? Greater than 0.62, so right-hand side shading. But the standard normal table gave me this. So how do we work it out? Use geometry. The total area is 1 because that's the total probability of 100%. So we are doing 1 minus of left-hand side. We have to do this computation. So 1 minus 0.7324, here's the answer. A little bit more accurate than what you have got with this 4 decimal digits only, because Mathematica has more decimal digits. But if you use 4 decimal digits, you're going to get perfect answer by itself. Okay, so we went through right-hand side shading as well. And for right-hand side shading, remember, we have to do 1 minus. But if you try to memorize that as a mechanism, you're going to get out, I mean, there's so many, you're going to get, get drowned, basically. There are too many instructions. If you do the picture and then use your geometrical intuition, then it's not a problem. That's why I'm encouraging you to draw the picture. Here's another problem. Now, between these two, negative 1.64, we did it in lesson 1. Excuse me, problem A, part A. And 0.62, we did it in part B. We can combine those. Between these two, as a matter of fact, we are getting this kind of picture. See this down here, the big one here? That's the most important one, so I emphasize much bigger. So between negative 1.64 and 0.62, I want this one in the middle. How do I get that? If I want an area in between, the typical thing to do is subtract smaller area from bigger area. And basically this big green minus small blue, and you're going to get the middle part. Make sense? So this one we want here, it comes from this green minus blue. This big minus this little. So this green you found out from part B, 0.7324, I think. And then this blue, we did it in part A, 0.0505. That's basically what you need to do. 0.7324 minus 0505 and do your computation. That's what you get. So use geometry, draw picture. Okay, we are going to come back and do another problem, and this time we're going to do inverse problem. Let's meet again in the next video.